Welcome to Spring LIB.
So if we have Earth and then we have a satellite that is orbiting Earth, and the question is, uh, we know that the force of gravity changes only the direction of motion and does not change the satellite's speed. If this was the circular orbit, we know that gravity keeps the object in a circular orbit. Now, this orbit depends on the speed. We know that the velocity of this velocity is always tangential to the orbit, to the trajectory of the orbit. So this would be our tangential acceleration. Now we have a angular velocity, omega, lowercase omega, and that is actually describing the speed of the circular motion. However, this would be the force of gravity. And so essentially, at this point, because work itself is equaling the magnitude of the force times the magnitude of the displacement times cosine of theta, displacement, this is a linear term. And so this only depends on the velocity. And when I say velocity, the translational velocity. And so what happens is that then when you're calculating work, because the force of gravity is perpendicular to the direction of motion or the tangential velocity, we then know that the work done by gravity is equaling 0 joules in uniform circular motion. So that it would be our answer. We then know that the work done on the satellite by the gravitational force is 0, and that is again because the force of gravity is always perpendicular to the tangential velocity or the displacement of the actual satellite. Now, in terms of a circular orbit, of course, the displacement will always equal 0 because this is going to continue going around and around in a circle, and it'll always end up in the same place that it started. And so, by that fact, also, that's another reason why the work done by gravity is equaling 0 joules. And so, again, um, you simply have to just take into account always drawing free body diagrams is going to help you figure out essentially conceptual problems like these. That is the end of the solution. Thank you for watching.